Okay, so what we're going to do now is make a transition in Chapter 1 from the first difference of means test that we did, which is what I describe as the one sample difference of means test, and then we'll go to the two sample difference of means test, which starts on page 161 in the text. Now, I'm going to show it in the context of this sheet here, though, which is from the first day of class, and we've shown it several other times. And if you'll recall, on our first example, which started on, I believe, page 155 in the text, we took a sample of 10 light bulbs, so n equals 10, and we tested the average life of those light bulbs, and it came out 2,090 hours. Okay? Now, they had had some type of a treatment from a device which was supposedly supposed to improve how long the light bulb lasts. The hypothesized population mean in that first problem was mu equals 2,000 hours. Okay, in other words, light bulbs had been advertised to last for 2,000 hours, but with this new device, supposedly the life of a light bulb should improve to be something greater than 2,000 hours. So the first exercise that we did in Chapter 10 was what I call the one sample difference of means test, where we were trying to test whether our observed sample mean of 2,090 hours was statistically significantly different from the traditional life of light bulbs, that being 2,000 hours. And again, if you'll recall, when we compared our observed mean to our hypothesized mean, Megastat gave us a p-value of 0.008. Since that was less than our alpha of 0.05, we rejected the null hypothesis, and we concluded that the new device in fact was effective at helping light bulbs last for more than 2,000 hours. Now we go to the second example in Chapter 10, which again starts on page 161. And in this instance, rather than compare one observed mean to an hypothesized value, we're actually going to compare the mean for one group to the observed mean for another group. Okay? And what happens in this exercise is that I think Ora said he had a group of students in a class at 10 o'clock in the morning, which we'll call that sample number 1. And he had another group of students at 11 o'clock in the morning, and we'll call that sample number 2. And he calculated I think it was the mean test score for sample number 1. He calculated the mean test score for sample number 2. And then we used the t-statistic to compare the mean score for sample number 1 to sample number 2. So again, in the first part of Chapter 10, we compared one observed mean to an hypothesized value. Now what we do is we go on, and in the second part of Chapter 10, we actually compare two observed means, the sample mean for Group 1 and the sample mean for Group 2, to begin to identify whether the difference between these two groups is large enough to conclude that the populations from which they came, population number 1 for sample 1, population number 2 for sample 2, whether the differences between these two groups is large enough to conclude that the populations from which they came are also different from one another. So now what I'll do is I'll go directly into Excel, and I'll show you on a step-by-step process how we go about empirically testing using the difference, the t-test, to compare the mean for Group 1 to the mean for Group 2. Okay, now, again, this data is located in Chapter 10 already, but I went ahead and created it in Excel. And you see here Oris has a group of students at 10 o'clock and a group of students at 11 o'clock. Now notice that he only used 10 students from his 10 o'clock class, and he used 15 students from his 11 o'clock class. So one thing to note here is that when we do the two-group difference of means test, we don't have to have the same number of observations in Group 1 as we have in Group 2. That's a key point, okay? So the sample sizes don't have to be equal. So I went ahead and I calculated some descriptive statistics using Excel, where we've got 10 elements in group 1, 15 elements in group 2. Now we see here that the observed mean, so this would be x bar sub 1. So the sample mean for the 10 o'clock class is 152. The sample mean for the 11 o'clock class is 146. We're not so much interested in the fact that these two values differ from one another. What we're interested in is the difference between them large enough to conclude that there's a statistically significant difference between the groups? The difference between group 1, 152, and group 2, 146, that difference could just be due to random error or chance, okay? The beauty of the two-group difference of means test, it gives us an empirical way to assess, is this group statistically significantly different from this group, okay? So the first thing I'll do, in fact I always do this in Megastat, is I go to add-ins and then I go over to Megastat, and before I run the difference of means test, I always run my descriptive statistics just because I like to have that to look at in case I find anything peculiar. So notice here that I highlight, not only do I highlight the test scores, but I also highlighted the columns 10 o'clock and the column 11 o'clock. That gives me my labels. And here we'll ask for the mean, we'll ask for the sample variance and standard deviation. Not really too concerned about the minimum, maximum, and range. Okay? And then for the input range, let me just clear this out and make sure that I show you once again. For the input range, we highlight the column labels and then all the way down to the last observation. So now we're ready to click on OK, and this will give us the descriptive statistics output. And there we have it. We have 10 students in the 10 o'clock class, 15 in the 11 o'clock class, and our sample statistics are basically the same as what we had created in Excel. So now I've got that on my sheet. You might see down here that's entitled Output. When I do Megastat in just a moment here, the Megastat output will be immediately below my descriptive statistics. That's why I do the descriptive stats first. So now I go back to my data. I'm still at my add-ins tab. So now I click Megastat. Now notice what I'm going to do here. I drag down to hypothesis test. In the earlier example, we compared one observed mean to an hypothesized value. Now what we're going to do is compare two independent groups. Let me just briefly mention it's two independent groups because if you're in one group, let's say the 10 o'clock class, you can't be in the other group, the 11 o'clock class. So that you know that your groups are independent of one another if membership in one group precludes membership in the other. You know, if you're a male, you can't be female, okay? So, so we'll click on this. Let me just clear everything out once. Alrighty. So it asks for group 1. So I highlight, notice I include the column label for group 1 as well as all 10 observations. Then I go to group 2. I include the column label for group 2 and all 15 of those observations. Be careful that you don't inadvertently include these values down here because that will cause your results to be inaccurate. Now the hypothesized difference, here we have the hypothesized difference at 0. We have no reason to believe that one group should score higher than the other. Because we have a small sample size, 10 and 15, we need to work with the t-test. Now notice here we have options of pooled variance or unequal variance. I'm not going to attend to that in this mini lecture right now, but just take my word for it that we want to use the pooled variance. Our alternative hypothesis is going to be a two-tail alternative where we hypothesize that the two groups are not equal to one another. Again, we'll work with a 95% confidence interval, which is the same thing as saying we're willing to accept a 5% chance of a type 1 error, and we'll again ask the computer to display that. So now that we have our table ready, we just click on OK. We get our results. And again, consistent with what we've seen up until now, these descriptive statistics are exactly what we've previously seen. I'll not take you through all of these numbers here, but let me just remind you that we hypothesized that there would be no difference in the average exam score between Group 1 and Group 2. Our observed t-value was 2.572, and notice here our observed p-value is 0.017. Well, our critical p-value is 0.05, so since our observed p-value of 0.017 is smaller than our critical value of 0.05, we reject the null hypothesis, and we indeed conclude that these two groups are not equal to one another. So if I direct your eye back up to the mean scores for each group, 10 o'clock had an average score of 152. The 11 o'clock class had an average score of about 147. So we conclude that the 10 o'clock students scored higher on this exam than the 11 o'clock students did. And again, we're drawing that conclusion not just because 152.3 is greater than 146.6. We expect those two sample means to differ because of random error. We conclude that 10 o'clock students on average scored higher than 11 o'clock students specifically because of our observed p-value of 0.017 is smaller than our critical p-value of 0.05. So that's the two-group difference of means test with independent groups.